Hi guys, welcome to part 2 of this 3-part video on patterns. If you're still with us, you're awesome. Hi guys, welcome to part 2 of this 3-part video on patterns. If you're still with us, you're awesome. So without further ado, let's dive right in. Our first question says, you're given a quadratic sequence and you're supposed to write down the next term of that sequence. So we're given 2, 3, 10, and 23. So as per normal, let's get the difference between 2 and 3, that's 1. Difference between 10 and 3, that's 7. And the difference between 23 and 10, that's 13. Just going to indicate the space of the next term that we need. So this is our first difference. Now let's go to our second difference. So the difference between 7 and 1, that is 6. The difference between 13 and 7, that's 6. So this is our second diff. So now we will have to add a 6 to the 13. So that is 13 plus 6, that is 19. And then we're going to have to add 19 to 23. So 23 plus 19, that is 42. And that is our the next term which was required. Our second question says, determine the nth term of the sequence. So guys, you'll recall that the general formula for a quadratic sequence is an squared plus bn plus c. So we must get a. The formula for a is a equals the second difference over 2. So that is so our second difference, we remember that it was 6. So that is 6 divided by 2. So that is 3. And then we're going to look for b, and the formula for b is the first difference of the first term of the first difference. So that is f1 minus 3a. So that is equals so going back to our first difference, so you will see that the first term is 1. So we're going to have 1 minus 3 into, we have already found a to be 3. So that is 1 minus 3 into 3. So 1 minus 3 times 3, that's going to be minus 8. Now for c, equals t1, which is the first term of the sequence itself, minus a minus, sorry, I've just run out of space here, but it's minus b. So that is the first term of the sequence, that is 2. So we're going to have 2 minus a is 3 minus into minus 8. So that will give you an answer of 7. And then we need to write the general formula. So now we just need to take the values of A, B and C and substitute onto our general formula here. So that was Tn equals 3n squared plus, that is going to be minus 8n plus 7. So that is our general formula there. In this question, we're given an arithmetic sequence, and it says calculate which term of the sequence will have the value of minus 140. So we were given 35, 28, and 21. The nice thing about an arithmetic sequence is that it has only one difference. So that is 28 minus 35, that will be a minus 7. And 21 minus 28, that will be a minus 7. So the general formula for an arithmetic sequence is Tn is equals to 8 plus into n minus 1, all multiplied by the common difference. So A represents the first value, which is 35. So that's 35 plus n minus 1 multiplied by negative 7. So that's 35. N times minus 7, that is minus 7n. Minus 1 times minus 7, that's plus 7. So that would be equals 35 plus 7, that's going to be 42 minus 7n. So now we just need to substitute minus 140 for Tn. So that's minus 140 equals 42 minus 7n. So minus 140, taking 42 to the left hand side, I will change the sign. That's 42 equals minus 7n. And we just need to divide both sides by minus 7, and that 7 cancelled. We're left with n equals, so put that in the calculator and you'll get the answer. N equals 26. And you can prove this by substituting back the 26 back into this equation like so. So you have 42 minus 7 into 26, and then just see what the answer will be for that. So guys, this question asks for which value of n will the sum of the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in question 2.1. So guys, this question is asking for the first or for the sum of the first terms that will be equal to some term, any term in the quadratic sequence. We don't know what that term is. So all in all, we're looking for n here. So what we need to do is to first get the formula for the sum of the arithmetic sequence. So we have Sn equals n over 2 into 2a into n minus 1 multiplied by d. So on the quadratic sequence, we're only going to look at the general formula that we got from the questions above. So that is Tn equals 3n squared minus 8n plus 7. So now we're going to substitute the values of the arithmetic sequence that we know into this sum formula of the arithmetic sequence. So we have n we don't know over 2. We have 2 into, we know the first term of the arithmetic sequence is 35. All this multiplied by n minus 1 multiplied by the common difference of the arithmetic sequence, and that is minus 7. So now we need to simplify this, and we'll have n over 2. So 2 times 35, that's 70. And then we have minus 7 times n, that's going to be minus 7n. And we have minus 7 times minus 1, that was going to be plus 7 equals. So that's n over 2. 70 plus 7, that's just 77 minus 7n. So now we have a simplified formula. So now we need to equate this formula to this one. So we will have n over 2 into 77 minus 7n equals, that's 3n squared minus 8n plus 7. 3n squared minus 8n plus 7. So now we'll first take care of the fractions. So all we need to do is multiply by 2 here and multiply by 2 this side. So this 2 will cancel that 2. Now we'll be left with n times 77, so that's just 77n. N times minus 7n, that's minus 7n squared, equals 2 times 3n, that's going to be 6n squared. 2 times minus 8n, that's going to be minus 16n, and 2 times 7, that's just going to be plus 14. Now we can move everything to the left hand side, so we'll have 77n minus 7n squared equal sign minus 6n squared plus 16n minus 14. It's going to be equals to 0. So now looking at like terms, we have 7n and 77n, and 16n. So that is going to be, so we'll have 77n plus 16n, that's going to be 93n, a positive one, 93n. And we also have a 7n squared minus 6n, that's just minus 7n squared minus 16n squared, 6n squared, that's going to be minus 13. n squared, and then we're just going to be left with a minus 14 equals 0. Just highlight that. So now guys, you can go ahead and try and factorize this, but what I'm going to do is I'm just going to put this in a quadratic formula and solve. So n will be equals to minus b plus minus the root of b squared minus 4ac all over 2a. So now we just substitute those values there. So we have minus into, for b, b is 93, so 93 plus minus the root of b squared, so 93 squared minus 4, sorry guys, that's minus 4 into a is minus 13 and c is minus 14. So that it's minus 14 all under a root, and then all divided by 2 into minus 13, which is a. So now guys, you can just go ahead and put this into a calculator. You don't have to exercise your brain with this stuff. So if you put this into a calculator, you'll find out that n will be equals to 7, and that is the nth term in the arithmetic sequence, that whose sum from the first term to the 7th term, or I can say this, the sum from the first term to the nth term, that value will be equal to the 7th term in the arithmetic sequence. So just to fix my last sentence there, that is to the quadratic sequence, not to the arithmetic sequence. So our last question is a geometric sequence, and we're given that T5 equals 9 and T9 equals 729, and we're supposed to determine the constant ratio and then go determine the 10th term of this sequence. So what we can do is we can look at the general formula, which is Tn equals a multiplied by r to the power n minus 1. That's the general formula for a geometric sequence. Now we can substitute what we're given into this sequence. So we're given that T5 of this geometric sequence is equals to 9. So we'll say 9 equals a to the power r, 8 multiplied r to the power 5 minus 1. And also we can substitute for the ninth term, so that's going to be 729 equals a multiplied by r to the power 9 minus 1. That's 9. Sorry. That's 9. So what we can do here, guys, is we can solve for the value of r, which is the common ratio, which is the one that we're looking for. So we can just we know that a in a geometric sequence or in any sequence is the first term, and the first term will always be the first term. So we can equate the value of a, or we can equate a in order to solve for r. So now what we can do is we can solve for a, make a is the subject of the formula. We have, so we can now just divide by the expression now. So we have a equals 9, divide by the expression r, and we can simplify it. So that's 5 minus 1, so that's 4. And then a for this side will be equal 729 over a times r to the power 8, because 9 minus 1 is 8. So that's r to the power 8. Now we can equate the values of a equals a, and then we can say 9 over r to the 4 equals 729 over r to the 8. So now we can cross multiply, so we will have r to the 4 multiplied by 729. That's just going to be 729 r to the power 4 equals this is 9 multiplied by r to the power 8, so we have 9 r to the power 8. Now we need to get r to be alone and the numbers to be alone. So what we can do is, in order to get rid of 9 from the right hand side, we can divide by 9. What we do on the right hand side, we need to do on the left hand side, so divide by 9 this side as well. And in order to get rid of r to the power 4 on the right hand side, we need to divide by r to the power 4. So that's going to be r the 4, but now we need to do it on the left hand side, so that's r to the 4. So this will cancel that, and the 9 will cancel the 9, so we'll be left with 729 over 9 equals r to the power 8 over r to the power 4. So 729 divided by 9, that is just going to be 81 equals r. So now we can just bring this r to the top, and when we bring r to the top of the division line, the sign of the power will change. So we have r to the power 8 multiplied by r now we change the sign, that's going to be minus 4. So when you bring a variable to the top of the division line, and its power will change signs. So now we have 81 equals r. When the bases are equal, you can add or subtract the powers. So we have 8 minus 4. So 81 equals 8 minus 4 is just going to be 4. Now we should get rid of the root of the power. So we'll just go root, but however the root will have a 4, and we'll go root 4 here. So this 4 here will cancel with that one, and we're going to be left with r equals 3. So that's our common ratio there. Now we're supposed to calculate the 10th value, or the value of the 10th term, but however we still don't know a. So we can use any of these equations here to solve for a, and I'm going to use the easiest one. So we have a equals 9 over r to the power 4. So a equals 9 over r to the power 4. Let me just make sure. Yes. So now we just need to substitute. So that's 9 over the value of r is 3 to the power 4. So just put that in the calculator and you'll get that a equals 1 over 9. So now we can calculate the 10th term. So we have Tn equals a r to the power n minus 1. So now we have all of these values. So 10 T10 would be equals to, we know the value of a is 1 over 9 multiplied by the value of r, which is 3 to the power 10 minus 1. You can go ahead and plug that into a calculator, and you'll get that will give you an answer of 2187. So that's our solution. And just like that, guys, we end here, and I will see you on part 3 of this of the patterns. And thank you very much for watching. I'll see you on the next one.